Alright, let's test you quickly. Which one is correct? 0.00072 is equal to 7.2 times 10 raised to the power minus 4, or 7.2 times 10 raised to the power 4. So one of these is correct and the other is wrong. But if you don't understand this, standard form will confuse you every time. Now let's fix this. Hi, I'm Seun. Welcome to Maths with Seun, where I make maths simple and easy to understand. Let's get straight to the point. Before we talk about our standard form, let's take a look at these numbers. And 0.00072. This is a very small number. It's a number less than 1. And this is a very large number. You see, all these numbers are stressful to write, especially when you are in an exam or when it's even numbers bigger or smaller than this. That's why we use standard form, because standard form makes the number cleaner, shorter, and easier to work with. Now, standard form is usually written like this: A times 10 raised to power n. Now, your A, which is your front number, is usually numbers that are greater than 1 but less than 10. So it's just numbers from 1 to 10. And then your n, these are numbers that must be integers. It just shows how many times we have to move the decimal point. So these are your integers. It has to be an integer. It might be a positive or a negative integer. So what we are going to do is this: we are going to start with small numbers. Why? Because small numbers requires deep explanation, and it is the point where students get the most confused. So if you have the number 0.00072, the first thing you are going to do is move the decimal point until you get a number between 1 and 10. So if you are moving the decimal point, you're moving the decimal point from here. And remember, you are going to move the decimal point until you get a number between 1 and 10 from your left. So 1, 2, 3, 4. You made 4 moves. So 7.2 times 10 raised to the power the moves you made, which is 4, raised to the power 4. And because it is, you are counting down from the left to the right, it is in minus. Because you are counting down from the left to the right, it is minus. And that's why I would usually say that smaller numbers have negative power. Anytime you see a number that is less than 1, it is always going to have negative power, because you are going to count your moves from your left to the right. Alright, so let's work on another question to make you perfect this. This one says 0.03. If you are converting this into standard form, what would you get? So you count your moves again. Remember, you want to make sure that you get a number from 1 to 10. So this is where your decimal point is. We'll move decimal point from here. 1, 2. We have 3 times 10 raised to the power 2 minus 2. We made 2 moves. And remember, this is a small number. You counted from your left to your right, so you have minus sign in the exponent. Another question here is 0.0065. We are working on this. The same step, you are going to move your decimal. So you have 1, 2, 3. The first number to your left. The first number from 1 to 10 to your left, that's 6. So you have 6.5 times 10 raised to the power 1, 2, 3. You made 3 moves. So raised to the power minus 3. Another question would be 0.00015. So this is bigger than most of what we have been doing since, but it's still the same pattern. We're going to move our decimal from here down to the first number from 1 to 10 on your left. So 1, 2, 3, 4, 5. So that's 1.5 times 10 raised to power minus 5. Remember, we made 5 moves. So 1.5 times 10 raised to power minus 5. Okay, for the last question, D, you have 0.00456. We are moving from our left down to our right. So 1, 2, 3. 4.56 times 10 raised to power. How many moves did you make? 1, 2, 3 minus 3. That's our answer. So remember, the first number to the left is where you are going to put the decimal point to. Alright, so now let's work with the larger numbers. Remember, before that, remember that your small numbers is equal to a negative power. The power is always negative. That's your minus sign. Alright, so working on the larger numbers now. If you have the number 720,000, it's a large number, fairly large. What you are going to do is you are going to count your move. Now, this time we are going to move from the left to the right again. So this is a positive power because it's a big number. Your big numbers will always have your positive power. So if you count again, we are counting like this. So this is 1, 2, 3, 4, 5. This time around we counted from our right to our left. That's 7.2 times 10 raised to the power 5 positive power. C is plus. Again, let's work on another example. Like to clarify it, everything. This is 2020. If you want to solve 2020 in standard form, what are you going to do? You are going to move your decimal from behind down 1, 2, 3. So that's 2.02 times 10 raised to the power 3. We moved from here to 3. And remember, it's a big number, so you have plus as your exponent. The sign there will be plus. Let's do another one. We have here 772,500. If you want to convert this to standard form, you're going to count from the back. 1, 2, 3, 4. So you have 7.25 times 10 raised to the power 4. We made 4 moves from the back. 1, 2, 3, 4. 7.25 times 10 raised to the power 4. Now, another one, a large number, 4 million. If you want to write 4 million in standard form, you can just write it as, you count your moves. 1, 2, 3, 4, 5, 6. So 4 times 10 raised to the power 6. Remember, plus 6. Your exponent is 6. So it is 6. 4 times 10 raised to the power 6. And that's how you get your answer. Now, most people will make mistakes, silly mistakes. They will make mistakes like, instead of making sure they only have one number to the left, they will have two numbers. If you have something like 720,000 and then you are putting 72 times 10 raised to the power 3, it is wrong. Why? Because the order of magnitude is not complete. 10 raised to the power 4 means that when you multiply 10 times 10 times 10 times 10, you have 10,000. So when they convert that the number into standard form and 10 raised to the power 4, it doesn't mean they are changing the number. The number is the same. It's just the form in which they are writing it that is different. And then when you have 10 raised to the power minus 4, it means 1 all over 10,000. If you have done exponent really well, you will understand that you are just actually shrinking the number, the size of the number. So let's test you now. The question 1 is 0.056. Question 2 is 3.4, 3,400,000. Alright, feel free to pause the video. Okay, for those of you that have done it, please make sure to comment in the comment section. Alright, so let's do this. You have 0.056 and you are converting to standard form. So you count from back again. 1, 2. So you have 5.6 times 10 raised to the power minus 2. Remember, your smaller numbers, you have minus sign in the exponent. For the larger numbers, you have plus sign with the exponent. So this one now, question 2, is saying 3,400,000. If you are converting 3,400,000 to exponent, let me do it down here. To exponent, we are going to count from the back. So 1, 2, 3, 4, 5, 6. So you have 3.4 times 10 raised to power plus 6. Larger numbers plus. Remember, small number minus larger number plus. And that's all you need to know about standard form. Quick recap, your standard form is usually written as A times 10 raised to power n. And your A must be between 1 to 10. Your power, if it is bigger number, you know. If it is smaller number, is minus. So if you understand this, you have already solved 80% of standard form problems, and this will actually help you. So if you like this video, please subscribe to this video and tell me in the comment section if you want me to do a part 2 to solve questions on this same topic. Thank you.